Hi, my name is Zach Pinkley. I have just finished my second year of college here at UAF, and I have spent the last few months here in Galena, Alaska, on the ACEP utility internship. Right off the bat here, I'd like to apologize in advance. I'm currently recording this presentation in my pontoon boat, which I've been living out of, and it's been a bit of a rainy day, and the barge is also working at the landing. So if there's any background noise that may get a little loud, that's the reason for it. But without any further ado, let's get this going. So here in Galena, I work for this company called Sustainable Energy for Galena, Alaska, otherwise known as SEGA. They're a large biomass project that is located here on the old Air Force Base in town. They are completely locally owned and operated, and their main goal is to provide heat for the Galena Interior Learning Academy, otherwise known as GILA. Along with providing heat and hot water for the Learning Academy, they also provide many other services all around town, which can range from dump maintenance to other contract works for the city, and even chopping wood for elders here in town.
Having explained what Sega does here in town, I'd like to talk a little bit about what I was able to do on this internship. In all honesty, I did a lot more than I can fit into a 15-minute presentation, but these three sections, I think, are the overall main focus, and I thought I'd talk briefly about the big tasks in each one of them. These first two sections, the matrix work and the field work, were actually very closely related, and I was able to pull them together by the end of the summer. The other category were some other not so related tasks that I still thought were significant and worth mentioning. The first thing I accomplished on this matrix section was I was able to gather literature and some charts for references. We used these to better improve the data that we had on hand and to also eliminate some assumptions that we were making in our equations when it came to our matrices. I was also able to conduct an experiment on the diesel fuel we use for the oil boilers. These oil boilers, they supplement the biomass boiler we have. And we had an energy value for the fuel in units of BTUs per pound, but I was able to find a value in BTUs per gallon, which is a much more practical number for us. Finally, I did some work on our heat production versus consumption model. This is one of our big main matrices that Sega uses to keep track of how much energy was needed and what helps determine future consumption predictions. But I'll touch more on that later. This field work, as can be assumed, it was the more hands-on and physical work that I did. These were the two main tasks in it, and very quickly, we were able to look at both past and future harvest plots. This picture down here is actually from one of the past harvest plots that was harvested, I think, 2 years ago, and we were there to check and look at the regrowth, the natural regeneration of the trees there. So along with doing that and looking at a possible future harvest plot, which is the timber cruise, I was also able to perform moisture content analysis on some of our supply of drying wood that we already had on hand. In the other section here, I was able to work with the city to conduct lighting cost analysis for their RACI grant. Later on, actually currently right now, we are installing some solar panels on the south wall of the Sega building, and I've been helping with that too, although that is still in progress, and I don't think it'll be finished by the time I leave here. And of course, there were a bunch of other really fun tasks that I was able to do that weren't related to much of this. For instance, this picture here, I'm actually putting these little grills back inside. I'm standing inside of our biomass boiler and putting things away. But yeah, moving on. For our heat production versus consumption model, all of the data is based off of BTU meter readings that we check once a month. Over the years, every once in a while, there's a few meters that actually either go down or they just end up missing a month or two here or there. One of the big things that I did was I was able to use the past data from all the way back in 2016 until the present and come up with a prediction of what these missing months were. For example, this graph and chart is for the Student Union building at Gila. which didn't have any readings for May and August of 2018, as well as March through May of this year. By using a prediction function in Excel, I was able to come up with a fairly accurate value that we could use to fill in for those missing blanks. Using this same prediction function, I was able to come up with month-by-month predictions for every building here on base for the entirety of the next heating season. These numbers could then be used to give us some rough idea of how much wood would actually be needed for the next year. Moving into the fieldwork section, I thought I'd talk about our future harvest plot adventure, or timber cruise. To do this, my boss and Sega manager Tim Kalki traveled out of town a few miles by four-wheeler to look at a possible future harvest stand, pictured here on the left in these maps. We actually did run into a significant problem on the way out there that took us a couple of days to solve, crossing this beaver dam and the creek that it created, which is pictured in the lower right corner. We actually just ended up walking across and then hiking the rest of the way to the stand on foot, which ended up being about 3 miles. But once we were there, we performed 3 timber cruise plots, and the plots are a way of gathering data so as to estimate the volume in a tree stand. It requires determining which trees are viable and measuring the height and diameter at breast height for those trees. This data was then used to determine whether it was worth harvesting this area or not. For the moisture content analysis, I was actually able to do this over the course of a week from practically the comfort of my own desk. The first step in this process was gathering our samples of wood chips that had been drying from 1 to 4 years. That was done using the wood chipper in the lower left-hand corner. After gathering our samples, each one was weighed immediately for an initial value before being left out to dry. To speed up the process, we had a little mini oven that we could use to dry one sample at a time, and this actually helped ensure that both the free and the bound water were all evaporated, so that all was left was the dry weight of the wood. After measuring the dry weight of the wood, we used these two values and the equation in the lower right-hand corner to determine the moisture content of the wood. This could then be used to determine the lower heating value, which is basically the energy content of the wood. It should also be noted that the lower heating value takes into consideration the heat of vaporization and the heat of fusion of water, because we assume that the wood we harvest in the winter will have to have the water thawed and then evaporated. It's at this point where the matrix section connected with the field's work section, because values from all of these tasks were then used to come up with values for not only the amount of wood to harvest, but also the amount of area needed to satisfy that wood, which we got from our timber cruise that we had conducted just a few weeks earlier. Having finished up the biomass focus sections, it's time to look at some of the other things that I was able to do this summer. The first task here is the RACI lighting analysis. The City of Galena is a recipient of the RACI grant, which allows them to make more energy-efficient improvements through government funding. In order to ensure that the funds are being used efficiently, analysis has to be done on these improvements. Over the past couple of years, the City of Galena has switched many of the lights in city buildings, as well as some of the school buildings over on base, to LED lights using RACI grant funds. I was tasked with determining the savings made, both in cost and energy usage, from this switch. After gathering data from the year prior and the year after the switch, I was able to determine that significant savings had been made, as shown here. The other task I wanted to mention is the solar panel installation project I was helping with. Sega and TCC worked together to design a 24 kilowatt, 70 panel array of solar panels to help power the biomass room and the Sega shop here on base. Installation began on Monday, August 12th, and should be completed on Saturday, August 17th after I leave. This long installation period is due to problems arising in the wall of the 20 panel section, which is not pictured. Me personally, I was able to help with extensively on the installation of the 70 panel section, and I was a significant driving force in getting it done as fast as it was. After learning how the array worked on the first day and developing a system on the second day, I was able to help drive our team to finish installing every panel that our equipment allowed us to install on the third day, which I am very proud of. Ultimately, this summer was full of some really amazing experiences, both on the job and off. From spending nearly 3 months living in a beach pontoon boat to four-wheeling to the tree stands and walking across beaver dams, every day was fun and unique and helped me grow professionally and personally. I know for a fact that I will cherish these memories, relationships, and experiences for the rest of my life, no matter where I am. Thank you.